Most people don't know what salinity actually is. It's conceptually simple, but technically challenging to define and measure precisely. Usually when salinity is being discussed, it is being referred to as practical salinity. Estimates are obtained indirectly from measurements of chlorinity, electrical conductivity, and less commonly specific gravity or refractive index. Estimates are on the practical scales for this.
However, true salinity is known as absolute salinity. Absolute salinity is defined as the mass of dissolved solids per mass of seawater. To date, scientists cannot accurately find absolute salinity. They can only estimate it.
It's also a common misconception that salinity includes just sodium chloride ions. Salinity actually includes compounds like magnesium sulfate, potassium nitrate, or sodium bicarbonate, which dissolve into ions throughout the water.
Another interesting fact is in the open ocean, all the ions in the water are in constant proportion to each other. This is known as the property of constant proportion. By finding the concentration of one ion in the ocean, you can calculate the concentration of all the other ions in the ocean.
Historically, the definition of salinity was based on chloride concentration. This method is still used today for historical continuity.
Traditionally, salinity was determined based off of chlorinity, and chlorinity was determined based off of a simple titration. Here, I'm going to do titration using the Moore method. I am using as a titrant silver nitrate. The amber bottle is because it is photosensitive. As an indicator solution, I am using potassium chromate. In the beaker, I have placed diluted seawater and 1 milliliter of potassium chromate solution. In the burette, I have placed our titrant, which is silver nitrate solution. As soon as you see red, stop the titration. Record your final amount of titrant. From here, we can do our calculation to determine how many chloride ions are in the seawater. A good analytical chemist can calculate the chlorinity just as accurately as a conductivity meter.
However, in freshwater, chlorinity ratios change, and salinity and chlorinity are in different proportions. Therefore, finding practical salinity based on chlorinity is not as suitable for lower salinities. Today, most practical salinity measurements are done with conductance.
Conductivity is the degree to which a specified material conducts electricity. It is calculated as the ratio of the current density in the material to the electric field that causes the flow of current.
Saline water is easy to measure conductivity in. Measuring the conductivity of water that has a low salinity is more difficult because the electrical conductance comes from the dissolved ions.
The equation that converts conductivity to salinity, along with the definition of all its terms, is very long and complicated.
However, the value of practical salinity is computed from electrical conductivity, which differs slightly from the true or absolute salinity. When measuring the salinity by conductivity, there is a risk of erroneous results at high concentrations of trace elements, additional mineral nutrients, or dissolved organic matter.
We calculate practical salinity from the measurements of conductivity, temperature, and pressure, whereas to date we derive absolute salinity from a combination of these measurements plus other measurements and correlations that are not well established. Calculated practical salinity is preferred over the actual measured in situ conductivity value because of its conservative nature with respect to change of temperature or pressure.
As mentioned before, absolute or ideal salinity, defined as mass fraction of salts in seawater, this is important conceptually for formulating rigorous descriptions and precise assumptions about the dynamical and thermodynamical behavior of a seawater system.